Hello guys, in this video we'll see how to perform the linear convolution in Matlab by using the Matlab command. For performing linear convolution we need to give two equations. They will give two sequences, then it will perform the linear convolution and we'll get the output. Even we can plot here. We'll see the code for that. First write the inbuilt simple Matlab commands. Yeah. Now the previous Matlab commands are all clearing the data. Now we have to write the code. Give the input signal as x of n. I'm declaring as x of n as x. I'm giving the input in command window. Next, declare the length of the sequence x. Then declare the n, that is time period. In discrete, the time period will declare in n, or otherwise we'll denote it as n. Yeah. Then for plotting the graph we have to declare the subplot. We want to plot the graphs on same sheet, so we need to declare the subplots. Then this is discrete signal, so we used to, for plotting the signal we need to use stem n comma x. Then give the labels, then give the title as x of n. Next, for declaring h of one more sequence, that is h of n, I will denote it as h. So I will copy the whole program, otherwise I will declare the h. Then follow the same steps what you did in the previous one. Declare the length of the n, then declare the subplot, declare n, declare subplot, then declare the stem, then declare the labels, then declare the y label, then title. After that we need to perform the convolution by using Matlab command. We have the inbuilt Matlab command for the convolution, that is convolve sequence 1 comma sequence 2. Otherwise we can give sequence n comma h. We can do it in that way. So I'm giving the convolution for n comma h, then display convolution using to get the output in command window. For seeing the values we need to display, then display y, it will declare the outputs. For plotting we are taking the length of the output here for plotting the graph, then declare n values, then subplot, use the third plot of the subplot. Next, go for stem, then give the labels, x label, y label, and then give the title. Output sequence graph or convolution graph we can give. Here we did one mistake. Yeah, this is LH minus 1. Save the program. I'm giving them as linear con, give it dot m extension. Now run the code. You have to give the sequence. For giving the sequence, give in brackets 1 otherwise you can give the space for 1 2 6 4 4 5. Yeah, wait for some time. You got the values, minimize it. For next sequence, oh, we didn't change the name there. The second sequence, 1 comma 2 comma 3 comma 4. Yeah, here one error is there in 27. We'll solve that error. That is in 27. Yeah, here we missed the colon. Save it. Once again run the code. Give the sequence in brackets. 1 comma 2 comma 3 comma 4. Let's check this is a given sequence. Yeah, keep this one in graph passage. Then this one is same. Give the second sequence also the same. 1 comma 2 comma 3 comma 4. You can give different values also. Now convolution using inbuilt command is the output of the after convolving x of n and h of n. The output is this particular thing: 0 1 4 10 16 17 and 12. Totally 6 values we will get. Yeah, now see the graph. How the graph is. Yeah, this is a graph. But one more thing, we are not getting the second output. The reason for that is check the code once. You didn't change the subplot values. That's a mistake we did. Now save it. Run the code. Give the same inputs. Now you got the first graph. Then give the second sequence as the first. Now we got the output same as that. Now we will get all the three outputs. Yeah, after convolving we will get the values as the particular thing: 0 0 1 4. This is the expected waveform. This is what linear convolution by using inbuilt Matlab command.